In this video, I am going to solve this problem. Here is given that cotangent of g of x is equal to 1 plus x square. Now we need to show that g of 0 plus 2g of 1 plus g of 2 is equal to pi over 2. The objective in this problem is basically to start off with the left hand side. So start off with this and then do some algebraic manipulation or trigonometric manipulation as well, and finally come up with the right hand side, which is pi over 2. Now the left hand side is right here. However, the given function is not exactly in the form of g of x. So somehow we need to get the g of x by itself. And by the way, doing that is not too hard. This is what's given, this one. All we need to do is just take apply cotangent inverse to both sides. Cotangent inverse. Now this cotangent inverse and cotangent are going to cancel out. That's going to give you a g of x is equal to cotangent inverse 1 plus x square. Now if I plug in the values 0 for x equal to 0, x is equal to 1 and x is equal to 2, then we are going to get g of 0, g of 1 and g of 2. If we do that, we get the following here. As you can see, g of 0 is this, g of 1 is this, and g of 2 is this. Now what I'm going to do, I'm going to simplify it. It's going to be cotangent inverse of 1, the first one, this one, plus 2 cotangent inverse of 3 plus cotangent inverse of 7, because if I simplify this, it gives me 7. Now we got to simplify it further. Now note that cotangent inverse of 1, I could write it as cotangent inverse of cotangent of pi over 4, because cotangent pi over 4 is 1, plus I could write this as 2 times tangent inverse 1/3, because that's what it is, the formula, the relationship between cotangent inverse and tangent inverse. And then similarly I could convert this cotangent inverse 7 to tangent inverse 1 over 7. Remember, in going from this line to this line, I have used the fact that cotangent pi over 4 is equal to 1, and the other relationship between cotangent inverse and tangent inverse, which is cotangent inverse of x is equal to tangent inverse of 1 over x. Now look, cotangent inverse and cotangent, they're going to cancel out. That's going to give you just pi over 4 plus 2 times tangent inverse 1/3 plus tangent inverse 1/7. Now we are going to apply some trigonometric inverse trig properties to simplify and combine these two. Now you probably do remember this rule. 2 tangent inverse of x is going to be equal to tangent inverse of 2x over 1 minus x square. Now I am going to simplify this middle term, 2 tangent inverse of 1/3, using this formula. In our context, our x is going to be 1/3. So if I do that, I get the following. Look, I have simplified this or converted this into this using this formula. My x is 1/3, so it's going to be tangent inverse 2 times 1/3 divided by 1 minus 1/3 square. And this term, they stay the same. Now what I have done, I have simplified it. 1/3 square is 1 over 9. So if I simplify this portion, I get this, and which finally comes down to this. Now at this point, I am going to use another formula to combine these two tangent inverses. Remember the formula that says tangent inverse of x plus tangent inverse of y is equal to tangent inverse of x plus y over 1 minus xy. In my context, x is going to be 3/4 and y is going to be 1/7. So if I do that, I'm going to get the following. So I'm going to get pi over 4 as it is, right? Now combining these two is going to give me the following. Tangent inverse x plus y 3/4 plus 1/7 divided by 1 minus 3/4 times 1/7. Now I'm going to simplify this, and once I simplify that, I get the following. So look what it is. After applying this, we got this after applying this formula, and then now I'm going to combine the numerators. So 3/4 plus 1/7. So I multiply 3/4 by 7 and divide it by 7. That gives me 21 over 28. Then I multiply 1/7 by 4 and divide it by 4. That gives me 4 over 28. Okay, just to show it to you on the side, this is what I did. 3/4 plus 1/7. So multiply it by 7, divide it by 7, multiply it by 4, divide it by 4. The reason I did that so that I have a common denominator. So that's going to give me 23. 7 times 3 is 21 divided by 28. 4 times 7 plus 1 times 4 is 4 divided by 28. 7 times 4, right? Now 21 plus 4 is 25 over 28. This is just simplifying the fractions. Similarly, I do the same thing in the bottom. When I do that, I get 25 over 28 in the numerator and 25 over 28 in the denominator. This one stays the same, so pi over 4 plus this and this cancel out. That gives you tangent inverse of 1. However, tangent inverse of 1 is nothing but pi over 4. So I have pi over 4 plus pi over 4. So that gives me pi over 2. By the way, this is exactly the right hand side of the equation. So we just showed it. So just to summarize things, here is what we have done in this problem. We have started off with the left hand side, and then we basically applied this formula, these two formulas. One is this one, okay, and the other is this one. And by applying these two formulas, we have come up with the right hand side. But of course, the right hand side, left hand side was given in terms of g of x, or g of 0, g of 1, and g of 2. And then to get to g of x, we just applied cotangent to both sides of the given function, and that's what it is. Basically, this problem is nothing more than just a straightforward application of these two formulas. Okay, that's what it is. I hope that this discussion was helpful. Thank you very much.